Hello everyone. Today's part is about combination of thin lenses. It is the last part of our section. In this part we are going to talk about some devices that use more than one lens in order to magnify the object. At the beginning of the lesson we talked about magnifying glass. Magnifying glass it's used to magnify or to enlarge words, some objects. It magnifies them, but it doesn't give very large magnification. So sometimes we need to see the details of an object. So in this case, what do we use? We use microscope, right? Sometimes we need to see a very far star. In this case, what do we use? We use telescope. So microscope or telescope, they do not only rely on one lens, they use more than one lens. So actually they use two lenses in order to give an enough magnification for the small objects. In this figure here, I will explain the working of microscope and telescope. Please pay attention with me. So here, first of all, this about microscope. Let's say that I want to see the details of a very small object. First of all, where do we place our object? Our object is placed below the microscope. Okay, so it's placed here. This is the very small object. It's placed below the microscope, and more precisely, it's placed below the objective lens. So the microscope, it has two lenses: the objective lens, which is the one directly above the object, and eyepiece lens, which is the one we look through. Okay, so focus with me, girls. The object is here. The object is giving rays in all directions. These rays will pass through the objective lens. Okay, by the way, what is the type of objective lens and eyepiece lens? Are they converging lenses or diverging? What do you expect? For sure they are converging. Why? Because only converging lens can produce an enlarged image, right or no? Diverging lenses, they always produce images that are smaller than the object. So for sure we are not going to use diverging lens if we want to enlarge the object. So the types of two lenses here is converging lens. Both of them are converging, okay, because we need to make our object bigger. Okay, so the rays coming from the object, they pass through the first lens. So I want to hear girls I want you to hide this part. So I will try to hold it. Okay, so first we will just talk about this part. So we will assume that the other lens, it's not present. Okay, this is the object. The rays coming here, they will pass through the the objective lens, they will bend inward, and they will meet at a point, and they will make a real image. Why the image produced is a real image? Because usually the object is placed where outside of the focal point, and we know that when the object is placed behind the focal point of a converging lens, the image produced will be real. Okay, so we focus first only on the first lens, as though the second lens is not present. Okay, so now we get this image we get it from the first lens. Okay, so after getting this image, we will what? This image, girls, it will work as the object for the second lens. Okay, now forget about the first lens. It does its work. It did its work, and now this image produced by the first, it is the object for the second lens. It is the object for the second lens. Okay, and here if you notice, this object, okay, for the second lens is where is inside its focal length, okay, and we know from the sixth case for image formation by converging lens that when the object is inside the focal point, okay, inside the focal length, and it means, girls, it's very close to the lens, the image produced will be what? Virtual. This is the only case that gives a virtual image. Okay, so now here, to don't so this one now, because we finished from the first part, okay, this one now, it is the object for the second lens, okay, it is the object for the second lens. So this is the object, the rays coming from this object, look, when they pass through this lens, they bend, but they do not meet here, okay, but if we extend them backward, follow the dashed lines, follow the dashed lines with me. If we extend them backward, they will meet at a point. So this intersection, it is the intersection point of the apparent path of the refracted rays, not the real path of refracted rays. Therefore, this intersection point, it gives us virtual image. And as you can see the virtual image, how large it is, okay, as compared to this image or this object, okay. So why it's upside down? Because for sugars, according to this real image produced here, which works now as an object, okay, it has the same orientation of it. Virtual image, we know that it's upright. Yes, it's upright when the object is upright. A virtual image in general, it has the same orientation of the object itself, okay. So this is everything about a compound microscope or microscope. So microscope, it uses two converging lenses. Why? In order to give greater magnification. First lens, it creates a large real image. So this image is the one created by the first lens, okay. Then as this one we don't see it actually, girls. This one, it's created inside the microscope, okay. What we see is the final result, which is this one, the final result. We see always this one, okay. So we don't know what happens inside, but this what happens. This one, it's the first, it's the one produced by the objective lens. Then this one, it works as an object for this, and then this is the last image formed by the microscope, okay. So the image formed by the first lens is located as though the second one is not present. The image of the first lens is therefore treated as the object for the second lens. The image formed by the second lens is the final image that we see. Now, this part you are not responsible for, but I will just give you an idea about it. If the image formed by the first lens lies on the back side of the second lens, what do they mean? They mean that if this image, it's not formed here, instead it's formed here, okay, in this case it will work as an object for this lens, right? Okay, it will work as an object, but this object will be called virtual object, and its sign will be negatives, a sign of P, okay. Maybe, girls, in the table that you have in the book, you saw this one, that P can be negative when the object is virtual, and for sure you didn't understand it, because it happens in such cases when, for example, here the image produced by this lens, it's not produced on this side, it's produced on this side, okay, and therefore this real image will work as an object for this one, for this piece, eyepiece lens. So this object for this eyepiece lens will be virtual and its sign will be negative only in this case, but we will not you will not take it, we will not work on it in any number. The same procedure can be extended to a system of 3 or more lenses. So maybe we have a microscope with more than 2 or more than 3, okay. When we want more accurate results, we use more lenses. The overall magnification is the product of magnification of separate lenses, okay. So that final magnification is the product of these two, the magnification produced by this one and the magnification produced by this. That's why we get a greater magnification at the end. Okay, let's see this visual concept together about microscope.
A compound light microscope uses 2 converging lenses to create a highly magnified image. The 2 lenses are called the objective lens and eyepiece lens. The lens closest to the object is called the objective lens. The object being examined is located at a distance of between 1 and 2 focal lengths from the lens. At this location, the objective lens forms a real image of the object near the eyepiece lens. The image is located within the focal length of the eyepiece lens. Because the image is within the focal length of the eyepiece lens produces an enlarged virtual image of the first image. The 2 lenses produce a greatly magnified virtual image of the object. Magnifications of 1,000 times are common in compound light microscopes.
So girls, here as you can see, this is the objective lens. The object is placed below it, okay. The rays coming from O object will pass through the first objective lens, will give us a real image. See, now we're done from the work of the first lens, okay. This image I1, image 1, produced by the first lens will work as an object for this lens, okay. So this is the object now for this lens, and this object, where is it placed? It's placed inside the focal point of eyepiece, FE, focal point of eyepiece, FE, subscript E stands for eyepiece, okay. So it's formed inside, and when the object is inside the focal length, it means it's very close to the lens. The image produced will be what? See the rays, how when they come and they enter the lens, they enter the eyes, they do not intersect here, we trace them back until we get the intersection point. This is the final image I2. So as observer, we get directly I2, the final image, okay. We don't see I1, which is produced inside the microscope, okay. So this is everything about microscope. Still we have refracting telescope, the same concept. See, in order, girls, why do we use telescope first? We use the telescope to see very distant objects. We see distant objects, okay, such as stars, anything in the space type. Here this is the object in the sky, is very far, okay. I want to see it, so that the object which is in the sky now, the rays coming from it, okay, are what? Are nearly parallel, because they have traveled what? Long distance. So these rays, because they're coming parallel, when they pass through converging lens, how do they bend? They bend inward. And you remember, it is the first case we talked about. When parallel rays come and pass through converging lens, they will bend inward and they will meet at the focal point. See, FO. What means FO? It is the focal point of the objective lens. So they meet at here. They make a small image, like point size image, okay, or like bigger a little, the size of a point, okay. This is the image produced now by the first lens in a telescope, which is called objective lens, okay. Where are we looking from? We are looking from here. through the eyepiece lens. Okay, the image produced now by the objective lens, it will be the object for this one, for the eyepiece lens. And the same thing, this image, okay, this eyepiece lens is made in a way like its focal point FE. I will say that FE is here. What means FE? It is the focal point of eyepiece lens. So this eyepiece lens is made in a way that its focal point is what, like behind the focal point of the objective lens. Okay, this to ensure that the image created by the first lens is inside the focal point or the focal length of the eyepiece lens. And in this case, because now the image created by objective lens is inside the focal length, okay, this image now, it works as an object for this, right? So the image of this object would be what? Virtual, because when the object is very close to the lens, its image will be virtual. See, the rays coming from this image, from this object, when they pass through the lens to the observer, okay, they do not intersect here. Instead, we trace them back and they intersect here, giving what? A greater and virtual image. Okay, always the virtual image produced by converging lens, it's enlarged. Okay, it's enlarged, larger than the object. So telescope, as you can see, it has the same concept of microscope. The only difference is, for telescope, our object is very far, so the rays coming from it are parallel. They pass through the objective lens, they meet at the focal point of objective lens. Okay, now this image is the object for eyepiece, okay, and it's inside the focal length of the eyepiece, so that's why the image of this object will be what? Will be virtual and larger. So girls, actually we have two types of telescopes. The type that we talked about it now, it's called refractor telescope or refracting telescope. Why it's called refracting telescope? Because it's based on the use of lenses, and we know that when light passes through the lens, it refracts. So that's why this telescope is called refracting telescope. And if you remember, at the end of the previous chapter, when we talked about curved mirrors, okay, the last part in that section was about reflecting telescope. So if you check it, you will see the last part of section 3, curved mirrors, in the previous chapter, chapter 13. It was about reflecting telescope. So we have two types of telescope: refracting telescope, the one that uses lenses, and we have a reflecting telescope, the one that uses what? Mirrors. Okay, mirrors, in order to see an image of a distant object larger than the real object. Okay, so refractors, they use lenses to concentrate incoming light. Reflectors, they use mirrors. The goal is always the same, is gather as much light as possible and concentrate it to a focus. This is everything for this section. We will see this module concept and we will be done with this section.
The arrangement of lenses in a refracting telescope allows distant things to be magnified. The lens of a refracting telescope furthest from the eye is called the objective. The object being examined is at an effectively infinite distance. The focal point of the objective is closer to the eyepiece than the focal point of the eyepiece. This causes a real image to appear very close to where the eyepiece is. The magnification power of the eyepiece causes a much larger virtual image to form. This allows distant objects to be observed in detail.